two masses of 6 and 2 are connected by this light inextensible string passing over a smooth pulley. 6 kg is at rest on a table. Then a third mass of 2 kg is let fall from a height of 1 meter, and it strikes the second mass of 2 kg and sticks onto it. We're asked to show that the 6 kg will rise to a height of 20. Okay, let's have a look what's going on here. We have this 6 kg, it's at rest on a table. It's going up over a smooth pulley, and there is a 2 kilogram mass here. And then a third mass is let fall from a height of 1 meter. It doesn't tell us how far the 2 kilogram mass is, so let's take this one as the other 2 kilogram mass. It's falling this distance here, a height of 1 meter, and it's going to stick to the other 2, and then 6 is going to come up off the table. So let's take the first 2 kilogram mass that's falling. What are we told? We're told it's let fall from a height of 1 meter, so it's at rest, so its initial speed is equal to 0. The distance traveled is 1 meter. The acceleration is going to be gravity bringing it down. And then AUS, we can use V squared is equal to U squared plus 2AS. We're going to be able to get the speed of this 2 kilogram as it hits the other one. V squared is going to be the 0 plus twice GS. So we don't have anything else there. What we do, we have S as 1, so 2G times 1. So V is equal to the square root of 2G. In meters per second. So that's the speed of this guy as it just about hits this guy. So then we have a closed system of 8 kilograms and then a new system of 10. So our system has changed from 8 to 10. So what's going on before is there's a 2 kilogram mass moving with speed, and there's an 8 kilogram mass at rest. And then what's happening next is that there's going to be the whole system moving with a speed of V. So this 2 kilogram, we've just worked out the speed of it to be the square root of 2g. And that will be time, that's the u, and then this u here is 0 for the at rest. So we have 2 root 2g is equal to 10v. So the speed of the new system is going to be 2 root 2g over 10, which is equal to root 2g over 5 meters per second. So we're asked to show that the 6 kilogram mass will rise to a height of 20 centimeters above the table. So show that S is equal to 20. So we need either S is equal to UT plus a half AT squared, which we haven't been given time here, so we're not going to use that one. So we're going to need V squared is equal to U squared plus 2AS to get the distance risen. Now we have V. We have U being root 2g over 5. The V is going to be 0 before as it stops, so we need acceleration then of the new system. So the acceleration of the new system, we're going to need to do our forces diagram. So we have the 6, we have the string, it's going up in this direction, we need this acceleration, and we have 6g holding it back. So we also have our 4 now. Our 4 is going to be connected. Well, the string is going to be sitting here, say, if you want to visualize it like that, the string will still be connected for T, and we're going to have 4g and A going down in this direction. So my equations, T minus 6g is equal to 6a, and 4g minus T is equal to 4a, giving us 2g is equal to 10a. So G is equal to, A is equal to 2g over 10, which is equal to g over 5 meters per second. Now acceleration, it's going to be slowing down, so that's going to be a negative acceleration. So does that give us all our information here? And you can see here we'd need a negative acceleration here. When we put our information in, 0 is equal to root 2g over 5 to be squared plus twice a, and we got g over 5, so you can see straight away here, oh, that's my negative acceleration, it's slowing down, times s. So we're going to get 2gs over 5 is equal to root 2 squared 2g squared over 25, 2g squared over 25. So if we divide by 2, divide by g, we're going to get 1 over 5 is equal to g over 25. Sorry, 25. Here my g wasn't fully in that square root, confusing me, so that squared shouldn't be there. So we're going to get s over 5. S over 5 is equal to g over 25. Now that g is going to be gone, isn't it? So s, that's a 1. So s is going to be equal to, well, you can say 25s. Making a mess of this. So I'll just go back after making a hames of that. Just no harm to just go back and do it again. So from here, we're going to end up with 2g over 25 is equal to 2gs over 5. So 10g is equal to 50gs. So I can divide across by 50g. To get s is equal to 10 over 50, which is 1 over 5. So s is equal to a fifth of a meter, which is 20 centimeters. Is that what we were asked to show after all this mess at the end? Please say 20 centimeters. It does. Thank God. This video is now over.